So what if an AI could learn from every single thought it's ever had? I mean, really learn from them. Not just to get smarter, but to get way faster and a whole lot cheaper. Well, that's the big promise behind this really cool new technique called Retrieval-of-Thought, or ROT for short. Let's dig in and see how it all works. All right, so let's get right to the heart of the problem. We've got these amazing, powerful AI models that can reason through complex stuff, right? But getting them to actually do it is becoming super slow and really expensive. It's kind of like owning a Ferrari that gets, 1 mile to the gallon. It's awesome, but it's just not practical. So the big question is, why? Why is making an AI think so darn resource intensive?
Well, the way we do it right now, the sort of gold standard for AI reasoning, is a method called chain of thought. And it's a really clever idea, actually. You basically ask the model not just for the final answer, but to show its work, to, think out loud and generate every single intermediate step it took to get there. And it works. It really boosts accuracy because it mimics how we humans think through a problem. But there's a catch, a hidden cost.
And that catch is, well, thinking out loud is messy. You know how it is. When a model uses this chain of thought method, it ends up exploring a ton of different paths. I mean, it goes down all these rabbit holes, hits a bunch of dead ends, and makes a lot of wrong turns before it finally, maybe, stumbles onto the right solution. And all that exploration, it generates a mountain of extra text, and that extra text costs time and, you guessed it, money. And here you can really see the difference. On one side, you have chain of thought. It's like wandering through a maze, all trial and error, leaving a huge trail of text behind. But retrieval of thought, that's totally different. It's like having a map, a GPS that's built from every past success. It just follows a clean, guided path and skips all those wasteful dead ends. So this brings us to the really big idea behind retrieval of thought. And it's so simple, it's brilliant. Why are we forcing the AI to reinvent the wheel every single time it faces a problem? It just doesn't make sense. Instead of generating every thought from scratch, the system learns how to find and reuse old thoughts that have already worked in the past.
And this isn't just some clever computer science trick either. It's actually based on how we think. It turns out, researchers were writing about this way back in 1980. They said that human problem solving is all about connecting the dots, taking little pieces of old solutions and recombining them in new ways. And that's exactly what ROT is trying to give to AI. That same powerful, creative ability.
Okay, so the whole framework really boils down to 3 simple but really important observations from the research. First, similar problems tend to use similar thought patterns. Makes sense, right? Second, just looking up a thought that's already been stored is way faster than asking a giant AI model to generate a new one from scratch. And third, if you just give the AI a good roadmap to follow, a correct reasoning path, it doesn't have to do nearly as much work. It generates way less text to get to the right answer.
So the question is, how does this actually work in practice? How does ROT connect the dots, find the right little pieces of thought, and stitch them together to help the AI solve a brand new problem? While the heart of the whole system is something they call a thought graph, the best way to think about it is like an AI's long-term memory, but specifically for reasoning. Every successful step in a thought process gets stored as a little point, a node, and these nodes are connected in 2 clever ways. First, they're linked in the order they originally happened. But second, and this is the really cool part, they're linked by what they mean. So a step about calculating a percentage might be connected to another step about finding a ratio, even if they came from 2 completely different problems.
So here's what happens when a new problem comes in. It's a pretty slick process. Step 1, Roti zips into that thought graph and finds the most relevant starting point. Step 2, it travels through the graph, kind of like a spider on a web, connecting the dots and building a custom step-by-step template just for this new problem. And finally, step 3, it hands that template over to the AI to use as a guide. No more wandering in the dark. Okay, so the theory sounds really cool, right? It's elegant, but does it actually work? This is the part I love, because the results are pretty wild. Let's take a look at the actual numbers. So the biggest headline here is speed. I mean, just look at this. By giving the AI a map instead of letting it just wander around, ROT can cut down the time it takes to get an answer, what we call inference latency, by up to 82%. 82! That is absolutely game-changing. And a huge reason it's so much faster is this. ROT just slashes the amount of text the AI has to generate. These little units of text we call tokens. By getting rid of all that wasted exploration, it cuts the number of output tokens by up to 40%. It's simple, really. Less work for the AI means a much faster process.
And here's why that should matter to pretty much everyone.
Fewer tokens means lower costs. It's a direct translation. The companies that provide these AI services often charge you based on how much text the AI generates. So, the research shows ROTs can cut the cost for each problem solved by up to 59%. That makes this powerful AI tech way more accessible for everybody.
This chart here really puts it all together. Yeah, sure, there's a tiny little bit of time it takes to look up the first thought in the memory graph, but it's practically nothing. And the time you save by not having to generate all those extra tokens, it's enormous. The net result is just a massively faster experience from start to finish, especially for those smaller and medium-sized models.
But here's the kicker, the part you're probably waiting for. You'd think that making things this much faster and cheaper has to come with a trade-off, right? Like, maybe the answers aren't as good? Well, nope. The research shows that ROT gets all these incredible efficiency gains while keeping the same level of accuracy as the slow, expensive methods. It's the best of both worlds.
So, as you can see, this is way more than just a clever little optimization. This is a fundamental shift in how we can make AI reason efficiently. Let's talk about why this changes the game.
The researchers looked at something they called path switching. Basically, it's how often the AI gets confused, gives up on what it's doing, and has to start over from a different angle. The old chain of thought method does this all the time. But because ROTs provides that template, it's like an anchor. It keeps the AI on the right track, and it cuts down on those wasteful detours by almost 82%. And you know what's really promising for the future? The whole system just gets better over time. The more problems it solves, the more examples you add to that thought graph, the more powerful it becomes. So a bigger memory doesn't just mean it knows more stuff, it actually makes the AI more accurate and better at its job. It learns from experience, for real.
So let's just wrap this all up. What does retrieval of thought really mean for all of us? Well, it means faster answers when you're using an AI. It means lower bills for the people building these amazing tools. And it points to a much more sustainable way to make AI more powerful, not just by making bigger models, but by making them smarter and more efficient. It really is a whole new way of thinking about AI reasoning.
And that kind of leaves us with one last question to chew on. This whole system, at its core, is about not reinventing the wheel. It's about systematically learning from what works. And if we can teach a machine to do that so effectively, it makes you wonder, what could we humans relearn from that same simple, powerful idea in our own lives?